Hello everyone. We have been discussing in our first Zoom online classes about the basic concepts of chemistry. That is the very first chapter. We had just started discussing the law of conservation of mass and the law of constant proportion. Actually, we have started with the law of chemical combination. Means if any chemical reaction takes place, it is based on certain laws. What are those laws? That is what we were discussing. In this video, I will start from the very beginning itself, once again. The reason is, I have heard 2 or 3 queries where 1 or 2 of you could not enter into the online classes because there were more than 100 participants. And one of you have mentioned that you couldn't hear anything, so you didn't understand due to that reason, of course. So maybe this is due to some technical problems, or the internet may not be that good at that point of time from your side. Anyway, whatever be the reason, I thought no one should be deprived. So let me discuss it once again. Obviously, we are going to discuss something new as well, not only up to the portion where we have discussed into the online classes. So let us begin. We have been discussing about the laws of chemical combination. Now, law of chemical combination means we are supposed to discuss about 5 laws basically. We'll begin with law of conservation of mass. Secondly, law of constant proportion. Third is law of multiple proportion. Fourth one is law of reciprocal proportion. And there is another one known as Avogadro's law. So these are the 5 things. I know at that class I had discussed about these 2, but let me begin from the very first law, that is law of conservation of mass. So let us start. Law of conservation of mass. So first we will define, then we will chemically prove that this law actually holds good. As per the definition, it suggests the total mass of reactant will be is equal to total mass of product. That means if it is A plus B giving rise to C plus D, and if we are talking about mass of A is equal to MA, mass of B is equal to MB, mass of C is equal to M of C, mass of D is equal to M of D. So as per the law, we should be able to write MA plus MB is equal to MC plus MB. So this is what the law of conservation of mass suggests. So this is the definition along with the mathematical way out. Now, if one question is asked, Write down the question, all of you. If the question is asked that, just a minute, that when (4.2 gram) of sodium bicarbonate is added to a solution of acetic acid weighing 10 gram, it is observed that 2.2 gram of carbon dioxide is released into the atmosphere. The residue is found of 12 gram. Show that these observations are in agreement with law of conservation of mass. Now let us see. So, as per the question, it is quite easy to understand that NaHCO3 plus CH3CO2H, these two are there. It is 4.2 gram and this one is 10 gram, right? And it is giving rise to residue plus carbon dioxide. Carbon dioxide is found as how much? Where it is 2.2 gram. 2.2 gram and residue is 12 gram. So we have to show that these are in agreement with law of conservation of mass. You must have seen the question, just I am erasing this part. So according to the question, you should be writing like this. Is the mass of the total mass of reactant should be is equal to total mass of product. Now see, the total mass of reactant should be, so if we are calculating this much only, it should be m of NaHCO3 plus m of CH3CO2H. much it is? 4.2. We are calculating this much only, okay? 4.2 plus 10 gram, so it becomes 14.2 gram. Is it okay? Now similarly, if separately we want to calculate total mass of product, there we will write mass of residue plus mass of carbon dioxide, which is 12 gram plus 2.2 grams. So it is 14.2 gram. According to that, so what we are getting is total mass of the reactant as well as total mass of the product. So hence it is proved that these observations are in agreement with law of conservation of mass. So this problem I have not discussed in the online classes. So whoever was there, whoever was not there, for both of them it is equally important. So it is the second law. Here it is written, a chemical compound always is the combination of same elements having same mass ratio. What does it mean? I have taken water here. If you are collecting it from tap water or if it is from rainwater, doesn't matter. The formula is always water, H2O. So the elements are hydrogen and oxygen in both the cases. If it is so, then obviously the amount of hydrogen present is 2 gram and oxygen is 16 gram in both the cases. So the weight ratio or the mass ratio will be 1:8. So that is what the law suggests. A chemical compound always will have the same element. Water, from whatever resources you collect the water, it will only have hydrogen and oxygen, and the weight ratio will always be 1:8, and it is applicable to any element. Now we are quickly going to see one numerical related to that. So let us see the numerical. First I am writing down the numerical. In short, I will be writing. So this is the problem. Question is 1.375 gram of cupric oxide. This was reduced by heating in a current of hydrogen. So it was passed through hydrogen, and the weight of copper that remained was 1.098 gram. So it gives rise to copper and water possibly, and the weight of copper is how much? 1.098 gram. This is the first experiment. In another experiment, in the question it is given like that: 1.179 gram of copper was dissolved in nitric acid. So it was dissolved in nitric acid, and as a result, copper nitrate was formed. So copper nitrate was formed, and it is also said that upon ignition, whatever you call it, if I ignite that, ignition takes place, it is converted to copper oxide. Now, the weight of copper oxide that is formed over here is 1.476 gram. We have to show that these data are in, we have to show that these are following law of constant proportion. So now it is probably the first problem where the things are getting slightly complicated. I hope it is clearly visible and I am audible also. Remember one thing, whatever internet connection you might have, whatever phone that you might have, it is impossible to produce same video quality in the online classes as you could see here in the video that I am preparing. So you have got to adjust, I have got to adjust, there is no other way. But yes, live classroom will have its own importance, but here in the video that I am preparing, obviously the content will be little bit more because the time that we get is little bit more actually. Anyway, still if there is any problem you can comment on these videos and you can directly mail it to me also. So we have to prove that these results illustrate the law of constant proportion. So let us see how it is done. So in the first experiment, what is there? Copper oxide is given and copper is also given. So copper oxide is how much? It is 1.375 gram. And copper is how much? 1.098 gram. So it is obvious that oxygen should be 1.375 minus 1.098 gram. And as a result, just you calculate how much you are getting. You are getting 0.277 gram. You can calculate this very easily. Now, we have to see the weight ratio. It is copper is to oxygen 1.098 is to 0.277. In the second case, let us solve it after a few seconds. The copper taken, how much copper was taken? It was 1.179 gram. And copper oxide that was formed is how much? 1.476 gram. So basically we are calculating the case of copper oxide in both the case. So if copper oxide is formed in both the case, obviously we are checking the ratio between copper and oxygen. So oxygen, how much oxygen is there? 1.476 minus 1.179 gram. How much we are getting? We are getting 0.297 gram. So here also, if you take copper is to oxygen, you will be getting as 1.179 is to 0.297. Now, if you carefully see, if you take the ratio, roughly you can calculate it by the way. You see, is not it 5:1 almost? Here it is, just a minute, 1.179. Here also if you check, it is almost equal to, we shouldn't say it is exactly, almost equal to, here also, it is it visible now? Just a minute. I hope it is visible now. Here also, it is almost 5:1. The exact value is not 5:1 but almost equal to. It is clearly visible, right? So what we could prove? That the value of copper is to oxygen here is this much, and here also the value is 5:1, which is following the law of constant proportion, because the law suggests that if copper oxide is prepared from whichever resources, the ratio should be 5:1 always. So slowly you start getting acclimatized or accustomed to solve this type of numericals. We will be discussing the next law, which is law of multiple proportions. I am erasing this. Next one is law of multiple proportion. As a result, law of multiple proportion means, let us first define that. It is being defined as, see, when two elements combines to form more than one compound. When two elements combines to form more than one compound, then if mass of one element is fixed, if mass of one element is fixed, then mass of other element bears a simple ratio to each other. What does it mean? I can understand the language looks a little bit complicated, but I will try to explain. Two elements combine to form more than one compound. Suppose A and B. So AB can produce AB and it can produce AB2 also. Okay. Suppose it is ABX and if it is ABY. There, if mass of one element is fixed, so here it is, A is to B should be 1 is to X, and here A is to B should be 1 is to Y, right? I think all of you have understood. Now, if mass of A is fixed, which is already fixed, then this B and that B, suppose this one is B dashed and this one is B double dashed, should be equal to X is to Y. This means this should be a simple ratio. Is it still getting difficult? Then I am giving you a very simple example. Suppose I take water. Okay. So water is a combination of hydrogen is to oxygen, and I take hydrogen peroxide also, which is also a combination of hydrogen is to oxygen, right? So carefully see, two elements combines to form more than one compound. These are not same compound. Then let us see, in case of water it is 2 is to 16, so it is 1 is to 8, and here it is 2 is to 32, so it is 1 is to 60. So what will be the ratio between these two oxygen? Oxygen of H2O is to oxygen of H2O2. These are just notation, okay? Normally we should not be writing like this, but it is just a notation to make you understand. ये बस दिखाने के लिए कि दो ऑक्सीजन अलग अलग जगह से आए हैं. In that case, it is 8 and it is 16. So for water, it is 8. Just I am writing it in different color so that it doesn't mix up. So it is 8 is to 16, which is 1 is to 2. What does it mean? See, two elements, hydrogen and oxygen, combines to form more than one compound, water and hydrogen peroxide. If mass of one element is fixed, so we have fixed the mass of hydrogen, which is 1 in both the case. Then the mass of other element means oxygen in both the case, bears a simple ratio, and based on that there will be numericals. So for that first day I am just stopping it here. We are going to discuss the theory of reciprocal proportion on the next day. which is much more complicated, and obviously some numericals related to this topic. Carefully see to it. If you are having any queries, do not keep any hesitation to ask me. But yes, while attending the class, be a little bit more sincere, because you have to come in time, you have to note down everything, and whatever discussion that will be done, you have to read and then come back on the next day.